This question's asking us to determine the relative velocity of a person with respect to the ground. And we'll look at what with respect to the ground means. Let's say we're at a vantage point on the ground. Maybe somebody's watching from that point. So we have a subway car traveling 20 meters per second to the west. And on that subway car, person's walking 1 meter per second east. So what would that look like to the person standing on the ground? We could tell that it would look a little bit slower. Just as an example, if the person was walking in the same direction as the subway car at maybe 1 meter per second, we could maybe see that this person would appear to be moving faster than 20 meters per second relative to the ground. Okay, so let's go back to the other example. With vector addition, we add them tip to tail. When we stack them up, we have the resultant as length from the tail of the first vector to the tip of the last vector. There's only two here and they're parallel, so it's actually maybe easy to see that this magnitude would be 19 meters per second west. But how would we calculate that? With vector addition, we're allowed to define any direction we want as positive. So in this case, let's try defining to the left as positive. That means anything traveling to the right is negative. Remember, vectors have a magnitude and a direction. So when we state the velocity of the person, given our definition, eastward travel is negative and westward is positive. So the person is moving to the east, therefore their velocity is negative. So anything to the right is negative. The train's moving to the left or the west, and so this is positive. The relative velocity or the resultant velocity is the sum of the two. The velocity of the train plus the velocity of the person. And so we have that as 20 meters per second plus -1 meter per second. And so you can see the resultant or the relative velocity with respect to the ground is 19 meters per second. And the positive direction is west. So we have positive velocity here. Our answer is a little bit dependent on how we define our directions. Say I did this question another day and I decided to define west as negative and east as positive. Well, that would have changed the sign, so I'm just showing this as an example. So the velocity of the train would have been negative and the person would have been positive. And you could see we would actually end up having negative 19 meters per second in the west direction. And so that's acceptable as well. It just really depends on what we define as positive and negative